Bismillahirrahmanirrahim. Now we are continuing from the forces topic for IGCSE and O-level students, and on forces topic, let's start from this question number 9. So the weight of the uniform bar is given in 1.543 is 10 newtons. So we have this is 10 newton. The weight of the uniform bar. This bar weight is 10 newton and is applying it at the center, and it is 100 centimeter long. So this is 100 centimeter long. Calculate the clockwise moment about the pivot. Calculate the anti-clockwise moment about the pivot. And does the beam balance tip to the right or tip to the left? So we have to find this. So this is 10 newtons is here at the center. So this is 10, its weight is exerting at the center. So this is 3 newton, and this is 10 centimeter away. So from this 40 to 50, this is a pivot point. So this gives a clockwise moment, that is 100 newton centimeter, and this gives 10 to 40, this is 30 centimeter and 3 newton. So this is 90 newton centimeter. So this is 100 newton centimeter, and this is high, so it will clockwise, it will move clockwise. Since the clockwise moment is greater than the anti-clockwise moment, so the beam will tip to the right. So it will tip to the right here at the right side. Question number 10. Describe how you could find the center of gravity of an irregular lamina. The center of gravity of a irregular shaped lamina. Suppose we have to find the center of gravity of an irregular shaped lamina. A thin sheet of cardboard like this. Make a hole A here in the lamina and hang it so that it can swing freely on a nail. Here we have a nail clamped in a strand, and it will come to a rest with its center of gravity vertically below A. So this is point, and to locate the vertical line above A, tie a plumb line, thread and weight to the nail, and with this line is stretched and mark position AB on the lamina, and then center of gravity lies somewhere on AB. Hang the lamina from the point C, this, and mark the plumb line CD, and the center of gravity on line CD must be at the point of intersection of AB and CD, and check this, and by hanging the lamina from a third hole D, and try balance it with the center of gravity on the tip of your forefinger, and it gives the center of gravity should be around here. A heavy box with a square base and height twice the length of the side. This is the height is high, this length is x length, and this is 2x. So to be transported by a lorry. A heavy box with a square base and a height twice the length of the side is to be transported by a lorry. Explain how the stability of the lorry or the box will affect if the box lie on its side on the van rather than its base. So if the lorry contains the vertical mass as shown in figure, then at any second inclination the object may topple, fall over whenever the vertical line falls. Its center of gravity falls outside its base. However, the heavy object lies on its side as shown below like this, then the chance of topple will be much lower because the center of gravity will not fall beyond its base, because the base is more in this case. Base area is increased. In figure this question number 11, figure 1.541 shows the force acting on a raindrop which is falling on the ground. This is, and A is the force which causes the rain to fall. This force is causing the raindrop to fall. Give the name of this force, the weight of the drop. This is the weight of the drop, and B is the total force opposing the motion of drop. Since one possible cause of this force, velocity of the raindrop with which it falls, don't increase the drag, so it will increase the drag force uh, in the upward direction, so it causes dragging. So this causes the reactions, so it's due to dragging force. This B force will exert in the upward direction. What happened to the drop when A is equal to force B? When force A is equal to force B, it means no net force, and net force is 0, so it will drop with a constant velocity. The raindrop will move downward with a constant velocity or at terminal velocity. A car is traveling at a constant speed of 20 meters per second. The reaction time of the driver is 0.7 seconds, and there is a road block 50 meters ahead. Calculate the driver's thinking distance. So the velocity is 20 meters per second and reaction time of the driver is 0.7 seconds. The road block is 50 meters ahead. Driver's thinking distance have to find. The thinking distance, it is the distance traveled during reaction time of the driver. It is the distance traveled during reaction time of the driver before brake applied. This thinking distance is the distance before applying the brake. So S is equal to Vt 20 meters per second at 0.7 second. So in next 0.7 second, this is a thinking distance. So the driver will move 14 meters. So the driver's thinking distance is 14 meters in this case. If the driver thinking time is 0.7 second, then it will move 14 meters ahead. Now the car comes to halt at a roadblock. Car halt at the roadblock. Braking distance, it is the distance over which the brake applied before which the before vehicle brought to the rest. So 15 meter minus 14 meter is 36 meters is the braking distance. So the braking distance is only 36 meters because thinking distance has been covered with 14 meters. So state two factors that can affect the thinking distance and braking distance. Thinking distance depends on the driver's reaction time. This will vary with the factors such as the driver's degree of tiredness, use of alcohols or drugs, eyesight, and the visibility of the hazard. So braking distance varies with both the road conditions and the state of the car. It is longer when the road is wet or dry or icy. So when friction between the tires and the road is low, then when conditions are dry. Efficient brakes and deep tire tread helps to reduce the braking distance. The braking distance becomes longer when the load carries by the vehicle is increased. So if the heavy mass is there, heavy vehicles take longer braking distance. So because they have a high momentum and mass is very high. This topic will be covered in the next